In this video, we are going to see how to convert decimals with integers and fractions to binary. In some scenarios, we may have a number in decimal that needs to be converted in binary, and it consists of both the integers and the fractions part. The simplest way to perform this conversion is to follow the following three steps. Step number one is to break the number into integer and fractional parts, then convert each part separately, and finally combine the results. We will look at a number of examples to try and understand the whole process of conversion of such decimals to binary. And as we said in the previous slide, we need to separate the integer part and the fractional part. In this example, 41.625, 41 is the integer part and 0.625 is the fractional part. When we are converting integers to binary, we carry out the process of division by 2, while on the fractional part, we carry out the multiplication by 2. So we start by looking at the integer part. Our integer is number 41, so I write that number 41 divided by 2, which we get 20, remainder 1. So the coefficient, that is n0, is equivalent to 1. Then 20 divided by 2 will be 10, remainder 0. Therefore, coefficient a1 is 0. 10 divided by 2 is 5, remainder 0. Therefore, a2 is 0. 5 divided by 2 is 2, remainder 1. Therefore, a3 is 1. And 2 divided by 2 will give us 1, remainder 0. Therefore, a4 is equals to 0. And finally, 1 divided by 2 is 0, remainder 1. And therefore, a5 will be 1. Remember, we say that this is MSB and this is LSB. That is from our previous video on how to convert decimals to binary. Therefore, number 41 to base 10 will be given as 101001 in binary. The next thing is to perform or repeat the same procedure when we are looking at the fractional part. And we said in fractional part, we perform multiplication. So we have a 0.625 multiplied by 2, which gives us 1.25. So I write 1 as an integer and 0.25 as the remainder, and the coefficient is a to minus 1, which is 1. The coefficients of fractional part are equivalent to the integers. Then I bring this remainder here, repeat the same procedure. 0.25 multiplied by 2 will give me 0.50. Therefore, a minus 2 will be equivalent to 0. That is equivalent to the integer. Similarly, I bring that remainder, which is 0.5 multiplied by 2, which gives me 1.0, and a to minus 3 is 1. And finally, we can have the last remainder, which was 0 multiplied by 1, which we just get 0, and means a minus 4 equals to 0. Therefore, 0.625 decimal in terms of binary will be given as 0.1010. So therefore, we need to combine the two parts, the integer and the fractional part. So when we combine the two parts, we have the number 41.625 with base 10, that is decimal, to binary will be equivalent to the integer part is 101001 point. The fractional part is 1010. And that is the answer of 41.625 in binary. In example number 2, we want to convert the decimal 120.7 to binary. And similarly, we are going to have this number in two parts, the integer and the fractional part, and we are going to start on the integer part. So I have number 120 divided by 2, which gives me 60 and a remainder 0. Therefore, the coefficient a0 is given as 0. 60 divided by 2 will give me the quotient of 30, remainder 0. Therefore, a1 is equivalent to 0. 30 divided by 2 is 15, remainder 0, and therefore a2 is also 0. 15 divided by 2 will be 7, remainder 1, and a3 will be given as 1. 7 divided by 2 will be 3, remainder 1, and a4 is equivalent to 1. And also 3 divided by 2 will give us the quotient of 1, remainder 1, which gives us the coefficient of a5 equals to 1. And finally, we have 1 divided by 2, which gives us the quotient of 0, remainder 1, and means a6 equals to 1. Therefore, number 120 in terms of binary will be given as 111100 in binary. Remember, we said earlier from the previous video that this is MSB and this is LSB. Or you can write A6, A5, A4, A3, A2, A1, A0. Okay, which is equivalent to this value. Then we move to the fraction part, and the fraction part in this case is that we have 0.7 and we perform the multiplication. So I'll have 0.7 multiplied by 2, which gives me 1.4. So I write the integer as 1 and the remainder as 0.4, and the coefficient is equivalent to the integer. So in this case, the coefficient a minus 1 is equals to 1. Then I bring this remainder here, then repeat the same multiplication. 0.4 multiplied by 2, which gives me 0.8, and I get the coefficient a minus 2 as 0. 0.8 multiplied by 2 will give me 1.6, so the integer is 1, while the remainder is 0.6. Therefore, a minus 3 is given as 1. That is the coefficient. That 0.6 multiplied by 2 will give me 1.2, and therefore a2 minus 4 is also 1. The remainder, which is 0.2, or the fraction part, 0.2 multiplied by 2 is 0.4. So I write the integer as 0 and 0.4 as the remainder, and a2 minus 5 is 0. 0.4 multiplied by 2 will be 0.8, and it means 8 minus 6 is equivalent to 0. 0.8 multiplied by 2 will be 1.6, and this is 8 minus 7 equals to 1. And this will go on and on and on, because we'll not get the definite answer. It will keep on repeating after the for sequence continuously. That is, it repeats within this, after this a number of bits, we repeat the same kind of a sequence. Therefore, we can say that 0.7 can be given as 0.101100110011 etc. This can be written as 0.10110 with an overbar to show those number of bits that keep on repeating. Therefore, when we combine these two numbers, we are going to have number 120.7 in decimal in terms of binary will be the integer part, which is 111000 point, that is dot 10110, and make sure not to forget to write the overbar to show that it is a recurring kind of a function, and this is to base 2. So for the practice exercises, convert the following decimal numbers to binary. Number 1, that is 187.33, number 2, 62.67, and number 3, 246.47. Make sure that you put or you list your answers or solutions on the comment section. Also, make sure to check our next video, which deals with a simplified way on how to convert decimals to binary. I'll give you a trick, a simple trick on how to convert from decimals to binary.